Today we're going to use something called the fundamental theorem of algebra. The fundamental theorem of algebra allows you to basically factor a polynomial that otherwise isn't factorable. So if I gave you this polynomial, x cubed plus 2x squared minus 5x minus 6, you'd probably assume, okay, 4 terms we need to factor by grouping. The first two have x squared in common. The second two have -1 in common, but then the parentheses don't match. That means it's not actually factorable. So you cannot factor this one using factor by grouping. So how do we factor and solve it if we can't use factor by grouping? So I broke this up step by step. We're going to do each step individually, and we are going to have to remember how to do synthetic division. Do you remember synthetic division from a while ago? We'll review it. Okay, the fundamental theorem of algebra tells you how many possible solutions the polynomial will have. And we've talked about this from time to time. I've just never really given it a name. So the degree of the polynomial is the total possible number of solutions. So this is a third degree polynomial. This one has 3 possible solutions. So then, down here, number of solutions, there are 3 possible solutions. Next, we're using Descartes' rule of signs. Now, the nice thing is you don't have to memorize what all these steps are called. That's my job. You just have to know how to follow these steps. Descartes' rule of signs allows you to determine how many positive or negative solutions there might be. The number of positive solutions is the number of sign changes or less by 2. Sign changes means anytime that these terms switch from positive to negative or from negative to positive is a sign change. So as you read this function from left to right, our first term is x cubed, that's positive. The next term is positive 2x squared, that's not a change. The next term is negative 5x, that's our first sign change. So I'm going to put a little check mark right here, that's our first sign change. Then -6. Did we change there? We changed to negative on the 5x. We're staying negative, so that's not a sign change. There's 1 sign change in this polynomial. That means there is 1 positive solution. So this is the number of changes. If there's 3 possible solutions and 1 of them is positive, how many of them are then going to be negative? 2 of them. Here's the weird thing about Descartes' rule of signs. Anytime it's an even number, it's 2 or 0. Because here's what could happen. We could have the square root of a negative number, in which case we would have nothing. Or we could have like something squared so that there was actually anyway, it's always or less by 2. So anytime it's an even, it's 2 or 0. We'll figure that out more later. The possible solutions come from the factors of the constant term divided by the factors of the leading coefficient. We're only going to be using polynomials that have a leading coefficient of 1, so we don't really have to worry about this. Basically, I want you to look at the constant term. In this case, it's -6. How can you multiply to get 6? What are the factors of 6? We can do 1 times 6. We can do 2 times 3. So, positive or -1 might be a solution. Positive or -2 might be a solution. Positive or -3. Positive or -6. There are 8 potential, we'll say 8 potential suspects. From these 8 suspects, we're going to find the 3 solutions. Here's where we use synthetic division. We're going to test these potential solutions. We're going to test the suspects to see which ones are actually the solutions. We do this using synthetic division. So if you remember synthetic division, we have 1x cubed plus 2x squared minus 5x minus 6. Now, here's the question. Which of these solutions should we test first? So here's my strategy. I know that there is going to be one positive solution. There might be 0 negative solutions, but I know there's definitely one positive solution. So I am going to test the positive numbers. That kind of cuts down the amount of work I have to do. So the first thing I'm going to do is test positive 1. This is where you put the numbers that you are testing. Okay, synthetic division. Drop your first number down. Do you remember the steps for synthetic division? Multiply the 1 times the 1 to get 1, and then add. 2 plus 1 is 3. Multiply 1 times 3 to get 3. Add to get negative 2. Multiply to get negative 2. Honestly, I don't even care what negative 6 plus negative 2 is. Is this number going to be 0? Not 0. When you get a remainder of 0, you found a factor. You found one of the solutions. So this one's not 0. 1 doesn't work. So we're going to do this again. 1, 2, negative 5, negative 6. This time I'll test positive 2. Two times 1 is 2. Add them, 4. 2 times 4 is 8. Add them, 3. 2 times 3 is 6. Add them, 0. Yay, we got 0. When you get 0, that means that 2 is one of your solutions. This is where we kind of bank on what we learned yesterday. If 2 is a solution, that means that x minus 2 is in the polynomial. The rest of the factored form comes from here. So we started with x cubed. We already got one of the x's out. So now this is going to be an x squared term. So we've got 1x squared plus 4x plus 3. Do we know how to factor that trinomial? Why, yes, we do. We're going to look for two numbers that multiply to give us 3 and add up to 4. That'd be 1 and 3. So that part factors into x plus 1, x plus 3. What are our solutions? Positive 2, negative 1, and negative 3. We just took a polynomial that you could not factor by grouping, and we factored it. Now, after watching that the first time, do I expect you to be like, oh yeah, I totally got this? No, this is the first time you have ever seen anything like this. So it's not going to be just innately easy, and that's totally fine. So if you are watching at home, I'm going to end the video after this. I'm going to start a new video for the next examples. So watch the next video. Don't slack, watch the next video.